Good afternoon. In today's video lecture, the topic is biochemistry, and we're starting our new unit. And in this lecture, I will be discussing enzymes and macromolecules. So make sure you are filling out your notes organizer and also the macromolecule chart. All right, so biochemistry. You guys should know by now that bio stands for life. And so biochemistry is the chemistry of life. But what is chemistry, and how does chemistry relate to biology? Well, chemistry is the study of the composition, structure, and properties of matter. And matter is anything that takes up space and has mass. So how does chemistry relate to biology? Well, in biology, we will spend a lot of time talking about chemical reactions. Living organisms, there are lots of reactions that occur in living organisms, and so we need to have a basic understanding of chemistry in order to further understand those chemical reactions that take place in the cells of organisms. Okay, so there are two types of reactions. You have a physical reaction that involves a change in the state of matter. So you don't have a new substance that's being created. So for example, when ice melts, you still have water. Like you began with water, you end with water. It's just a different form of water. A chemical reaction involves atoms or groups of atoms reorganizing into different substances. So a chemical reaction would be like rust on a can, or cooking an egg. Once you cook the egg, you can't change the egg back into its previous form. You've reorganized the atoms, and it's completely different. Okay, so when we talk about chemical reactions, we have to talk about chemical equations. And in a chemical equation, there are two parts to a chemical equation. You have the reactants and you have the products. And the reactants are what you start off with. So it's what is going into the reaction. And it's always to the left of the arrow. The products are what is produced. And it always, most of the time, the products are to the right of the arrow. And so, and you can look at the arrow as like an equal sign or a yield sign. Okay, so we have an example, a reaction that is on your notes organizer. You have carbon dioxide and you have water that's going into the reaction. And then you have glucose and oxygen that's being produced. So what biochemical process does this chemical equation represent? Do you guys know? You have carbon dioxide and water, and then it's producing glucose and oxygen. I'll give you a hint. Plants go through this process every day, or all the time. This process is occurring in plant cells. Okay, so this process is photosynthesis. And so make sure on your notes organizer you label the reactants and you label the products. And so you have the reactants to the left of the arrow. You have the carbon dioxide and the water. And then what's being produced is to the right of the arrow, the glucose and the oxygen. And you guys will get very familiar with this equation by the end of the semester. Okay, so when you talk about chemical reactions, you have energy diagrams that kind of show what's going on in the reaction. And so all chemical reactions either take in energy or release energy. And so the energy diagram just illustrates how the energy is being used or how it's being produced in a reaction. Okay, so every reaction takes a little bit of energy to start, and that is activation energy. The activation energy is the minimum amount of energy that's needed for the reactants to form into products. Okay, so now we have to talk about enzymes, and this concept is very important. It's critical that you understand enzymes. So enzymes are special proteins that help to speed up chemical reactions. They act as biological catalysts and they lower the activation energy. And so in this diagram, and you guys will have to draw this diagram, number 7. You see how how much energy the reaction requires without the enzyme. You see how high that hump is? But with the enzyme, it's like it lowers the energy that's needed for the reaction to take place. And so that's why enzymes are so important to living organisms, because they lower that activation energy that's needed, but they also speed up the reaction. So it doesn't increase how much product is made, and it does not get used up in the reaction. And so enzymes can be used over and over again, but they help us, they help living things go through all the reactions that they need to go through. Okay, so how do enzymes work? Well, with enzymes, you have the substance that's acted upon by the enzyme, and that is called the substrate. And then you also have the specific location where the substrate binds to the enzyme, and that's called the active site. And this right here, that is the active site, and that is where the substrate will bind to this enzyme. And so the enzyme and substrate fit together like a lock and key. So you see how the substrate, the shape of the substrate is complementary to the active site. It fits perfectly into the active site. And so a lot of times you'll hear enzymes are a lock, like they're like lock and keys. And so like you have a key that's specific to your lock. So say, for example, I tried to use my Nissan Altima key to get into a Porsche. That just won't happen because my key is for my car. It's not for any other car. All right, so enzymes are biological catalysts that speed up reactions in living organisms. In living organisms. And so here's that energy diagram again. And you see with the enzyme, it's like the amount of energy that's needed is much lower than without the enzyme. And so enzymes are used for lots of different processes that occur in living organisms: photosynthesis, cell respiration, growth, waste removal, and so forth. And so on the blog, I will have a link to this website. And so for number 11, you guys will have to click on the link and answer the question. And so just make sure that you go to that link so you can answer number 11 on your notes organizer. Okay, so now we're going to switch gears a little bit and we're going to talk about macromolecules. And so macro means large. And so macromolecules are large molecules that are formed by joining smaller organic molecules together. So there's a box in the middle of the macromolecule sheet, and it says definition from, and so make sure you guys are writing down that definition for macromolecules. Okay, so like I already said, macro means large. Another word for macromolecules that you guys will see are polymers, and poly equals many. And so polymers are made up of many monomers. Mono means one or single, and so the monomers are the single or smaller subunits of the polymers. And so monomers are the building blocks of polymers. And so in each square or each box for the organic macromolecules, you see like the building blocks. And so the building blocks are the monomers of those larger macromolecules. And so all biological macromolecules contain the element carbon. So make sure you guys get that information down in the middle. And so macromolecules are also known as polymers. Okay, so there are 4 major macromolecules that we are going to discuss: carbohydrates, lipids, proteins, and nucleic acids. Okay, so the first one we're going to talk about are carbohydrates. And so the building blocks of carbohydrates are monosaccharides or simple sugars. So glucose, fructose, those are examples of simple sugars. And you guys will realize that when you see the ending OSE, that should tell you right away that that is a sugar or a carbohydrate. Okay, so why are carbohydrates important? Carbohydrates are so important because they are your body's main source of energy. And so simple sugars provide you with fast-acting energy, but complex sugars provide you with long-lasting energy. And so a lot of times you will hear athletes before a big event, they will often eat a meal that is heavy in starches so that they can get that long-lasting energy. So they'll carbo load. And they're just trying to, load up on energy. Additional functions are that they are for structure, they provide structure and support. And here are some examples of carbohydrates. You got your grains, pastas, fruits, vegetables, and then in plant cells, cellulose is a major component of the plant cell walls, and humans actually cannot digest cellulose. So that's why it's important to eat your vegetables, because it helps keep your system moving. Some additional information about carbohydrates are that they are compounds. They are made up of carbon, hydrogen, and oxygen, hence the name carbohydrate. That's carbon, hydrogen, and oxygen. And it's in a ratio of 1 oxygen to 2 hydrogen atoms for each carbon. If you have 2 monosaccharides joined together, that's a disaccharide. And so an example of a disaccharide would be sucrose or table sugar or lactose. And then many monosaccharides join together to form polysaccharides, and those are complex sugars. Starches, glycogen, cellulose are some examples of those polysaccharides. Okay, so the next macromolecule we're going to discuss are lipids. And lipids, when you hear the word lipid, you should automatically think of fats. Lip equals fats. So lipids are fats, oils, and waxes. There is no true monomer for lipids, but it is made up of fatty acids, glycerol, and other components. So for the building blocks of lipids, you can put fatty acids, glycerol, and other components. Okay, so the primary function of lipids is to store energy. And so it also provides insulation. You see the walrus, it has a lot of blubber or fat, and that fat provides warmth for that walrus. It also prevents water loss. Lipids don't mix with water, and so lipids are hydrophobic. Hydro is water. Phobic means that it's faring. It's water faring, and so it does not mix with water. So if you add oil to water, you will see how the oil separates. It does not mix with the water. And this is important. And lipids make up our cell membranes, and that's important. Like when we talk about the role of the cell membrane, you'll see why it's made up of lipids. Also, there are waxes on plant leaves to like kind of reduce water loss. And then honeycomb is another example of a lipid. Here are some more examples. You got your butters, your oils, avocados, waxes, steroids. These are all examples of lipids. And I talked about hydrophobic. Lipids are hydrophobic. They're water-faring. And then you have some lipids that are solid at room temperature. Those are called triglycerides. And then you have some lipids that are liquid at room temperature, and those are called oils. Okay, so lipids with only single bonds, those are saturated fats, and lipids with at least one double bond equal unsaturated fats. Lipids with many double bonds are polyunsaturated fats. Okay, so the next macromolecule that I will be discussing are proteins.